Hey AP Stats, welcome to our first online lesson. So for today, I'm going to be going through the notes first. I'm going to give an example problem and then you guys will have the rest of the work to do on the Google form. So what we've done so far when we last saw each other is we've been doing significance tests for one proportion, just one. Life was easy. And we did a significance test for the Skittles if you were there in class on Wednesday, I think it was. So you have the null hypothesis and you have the alternative hypothesis. So we're going to continue doing that. Nothing has changed. It's still a state plan to conclude, except for now we go into two proportions. And the thing about two proportions is that we've already done this already with sampling distributions. And it's always going to be a difference of two proportions. You're never going to say, oh, the sum of two proportions. No. It's only differences. Okay, so let's jump right into the notes here. Your hypothesis will look a little bit different now. So here is what your null hypothesis, or as like you guys like to say, the hoe, is going to be still an equal sign, but it's going to be one proportion equal to the other proportion, which I denote here as P1 and P2. An alternative way that you might see this written sometimes, other way to write, is P1 minus P2 equals 0. This is equivalent to what I wrote here in red. I don't prefer this way that I wrote in gray. The reason why I'm showing it to you is that sometimes it might pop up in a multiple choice question. So where does this come from right here? I'm going to show you really quickly. So look at this red equation. We're going to do a little bit of algebra. So P1 equals P2. Well, what happens if I subtract P2 from both sides? Then I would get P1 minus P2 equals, this cancels out, you get 0. So that is where this comes from. I'm just moving around the pieces of my hypothesis. So if you believe me, we can continue. All right, the alternative hypothesis. We have, as always, 3 options because you could have any of these inequality symbols. And that would just be P1 is greater than P2, or maybe it's less than P2, maybe it's not equal to P2. An alternative way of writing these, I'm just going to do one example here, P1 minus P2 greater than 0. Again, I don't really prefer the gray, the way it's written in gray. I prefer the red. That has been the easiest for me. Okay, and so once you do your hypothesis, I wrote too big here. Once you do your hypothesis, as before, I always want you to define your parameter. So that means define P1 and P2. Okay, and I don't want you to say parameter equals, parameter is just what I call it. I want you to actually say P1 equals the true proportion, ... and then do the same thing for P2. All right, conditions. Business as usual, but a few things a little bit different here. So I know I'm just going to write out all 3 conditions. We have random, 10% rule, and then the normal condition, which for proportions is going to be the large counts condition. Okay, let's take a look at random really quickly. So this is what we know, and then I'm going to give you something new. So if there is a random sample, that's good because that means we can generalize our results to the population. Something new. If there is random assignment, so this is a throwback to when we were doing experimental design in chapter 4. If there's random assignment, the reason why we like random assignment you might remember this, is because you can prove causation. Remember, correlation does not equal causation. However, if your experiment has random assignment, then that means your results, you can prove causation, that say the number of rubber bands causes Barbie to go further down, something like that. Okay, so either one. Sometimes you'll have, so far we've only done random sample. If the example says random assignment instead, that is fine. That proves your random condition. All right, 10% rule. So I only want you to check this when we're sampling without replacement. What that means is sampling without replacement. What that means is basically every confidence interval, every significance test we've done so far has included sampling. Why is that, you say? Well, there was a random sample. So that means we were sampling, and you only check that to make sure that you're sampling. If you're sampling without replacement, it's okay, so that you can assume independence. So the hint today is that since I'm teaching you this new thing with random assignment, when there's random assignment, you don't need to check the 10% condition. Don't need to check for random assignment because there's no sample. All right, and then the large counts condition, that stays the same, but I want you to check for both samples / groups. We've only done this one time and it's been a while. Usually check this thing, n times p, n times 1 minus p, see if it's greater than or equal to 10. You're going to have to do this twice because there are 2 groups, 2 samples. Or, sorry, we're not. There's 2 groups or 2 samples. My bad. All right, so here's your example problem now that we have the notes. Again, feel free to pause the video as you need so that you can copy down the notes on your end. Here's the example. Mythbusters investigate the question, is yawning contagious? Here's a brief recap. Each subject was placed in a booth for an extended period of time and monitored by a hidden camera. 34 subjects were given a yawn seed. Okay, so 34 subjects given a yawn seed by one of the experimenters. That is, the experimenter yawned in the subject's presence before leaving the room. The remaining 16 subjects were given no yawn seed. Do these results give convincing evidence that yawning is contagious? So, first thing I noticed is that this is an experiment. If there's an experiment, it's not necessarily going to be a random sample of people who are the subjects. So I'm looking for the word or phrase of random assignment, and I don't see that. So I'm going to have to most likely assume that random assignment happened earlier. Okay, so just to give you guys some explanation here, a yawn seed isn't a physical seed, but it's just the experimenter is yawning in your face, trying to see if you will yawn. And if that happened to you, that means you got a yawn seed. If the experimenter didn't yawn, you were given no yawn seed. So let us keep going here. I'm going to scroll down a bit. They've given me some data in this table. So if you got a yawn seed, 34 people, 10 of them yawned. Okay. And I'm answering the question, do these results give convincing evidence that yawning is contagious? So I'm just going to walk you through what I'm doing here. To help you with the next problem. Okay, so in the state, the name of the test, remember when we were doing 1 proportions, it was just 1 proportion z-test. So the only thing that changes is, well, this is 2 proportions because you have 2 groups, the people who were given the yawn seed and the people who were not given the yawn seed. So I'm going to name this 2 proportion z-test. Okay, my hypothesis. P1 equals P2. So then yawning is not contagious. Okay, P1 is greater than P2. All right, let me give you some context here. So my null hypothesis would claim that yawning is not contagious. And my alternative is that yawning is contagious. Where does this come from? Let me show you. So typically, the very last line, evidence that yawning is contagious, this is almost always your alternative hypothesis on the AP exam. Like I literally just go right to the last sentence and I'm like, okay, what's my alternative hypothesis? I'll write that first. So what I'm saying here for the null hypothesis is that the proportion of people who yawn, so like this is 10 out of 34 and this is 4 out of 16, the proportion of people who yawn when they're given the yawn seed is the same as when they're not given the yawn seed. That's what my null hypothesis is. And my alternative is that, this is going to be P1, this is going to be P2. My alternative is that if you're given the yawn seed, you should be more likely to yawn than if you weren't. So that this proportion right here needs to be greater. I want to jump back and I actually want to calculate my p hats for yes yawn seed and then no yawn seed. Okay, so here's yes yawn seed. So this is actually my p hat, we'll call it p hat sub 1, if they yawned or not. So that would be 10 out of 34. If I put that in my calculator, I get 0.29. I'm going to calculate p hat for if you weren't given a yawn seed, no yawn seed. So this is p hat sub 2, 4 out of 16, 0.25. Okay, we're going to come back to these p hat values later. So back to here, I want to define my parameter now. So every time that you write a hypothesis, you're using variables. Defining the parameter means that you're defining what those variables are. And I actually have two different variables here. I have P1 and I have P2, so I'm going to define both of those. Okay. P1 equals true proportion of people who yawned with yawn seed. So the people who had the experimenter yawn in their face. Okay, p hat 2, oh sorry, not p hat, P2 is the true proportion. And then I kind of get lazy here and I just kind of do dot 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 and I do like little quotes to show that it's the same thing. But this is without a yawn seed, so then I'll say without, I spelled it wrong, without yawn seed, and that's okay. You can do that if you want to not write the whole thing. I still pretty much wrote a lot of it. Okay, so you have name of the test, hypothesis, you define your parameter. You would get 1 point there for the state portion of a significance test. Remember, this is a 4-step process and we're just doing the first 2 steps today. Okay, plan is the conditions. So I'm going to check all 3 conditions here. Random. If you remember, we didn't see anything about random sample or random assignment here. So I am going to assume that there was random assignment. Otherwise, we wouldn't even be able to do the significance test. So we always need to proceed. Assume random assignment. And the reason why we assume that, you don't have to write this next part down, so I put it in parentheses. It's so we can show causation. In the context of this problem, it means that so that I can show that when you get someone yawning in your face, it makes you yawn. Okay, 10% rule, the second condition. So there was no sampling done at all here, so we actually don't need to check. So on the AP exam, you're going to do what I do right now. You're going to write no sampling, don't need to check. Okay, last one, the large counts condition to see if we can use the normal curve for our calculations. All right, let's do this one first, and then I'll do this one second. So I'm going to use the same color to match here. All right, so the sample size of the people who got the yon seed, remember that was 34. So that's going to be n times p, so 34 times 0.29 equals 9.86. Ooh, that's not good. That is less than 10. Then 34 times 1 minus 0.29 equals 24.14, so that works. I know that I already got one of them that doesn't work. The first one, it's not greater than 10, but I'm just going to do I'm going to do this one too, just so that you guys can see. But if you got to this point, you could stop right there. You can say, wow, this is not normal. Actually, I take that back. You should calculate the other one too. Oops. Sorry. You should calculate the other one too. And then just say proceed with caution. So the sample size here was 16 times 0.25. That equals 4. Not good either. 1 minus 0.25 equals 12. Okay, so this one's greater than 10. This one was greater than 10. All right, so unfortunately, I do not pass the large counts condition, so I'm going to explicitly write fails large counts condition, proceed with caution. Okay. Good luck. The next problem that is actually going to be on your Google form, it's a little bit more straightforward. It's a lot more straightforward, actually. So go ahead and complete this in the Google form for me. After you do that, there will be some questions that are multiple choice. There's 4 multiple choice questions. All right. I will be available in office hours today if you guys have any questions or need assistance. Bye.